Welcome to qnawire.
In this problem, we're going to be looking at the graph of an electromagnetic wave traveling in a vacuum. Mathematical description of this wave is given to us by this equation here. Y equals a sine of 2 pi f times t minus 2 pi x over lambda. A is the amplitude. That's the maximum magnitude of the electric field. In this case, 156 newtons per coulomb. F is the frequency. They've given that to us as 1.50 times 10 to the 8 hertz. And lambda is the wavelength. Now, they didn't give us lambda, but we can easily find it if we recall that lambda is equal to c divided by f, where c is the speed of light and f is that frequency that they've given us. So you plug in speed of light, 2.9979 divided by 10 to the 8. The frequency, 1.5 times 10 to the 8. And you'll get that lambda is just 2. So now that we have those values, let's go ahead and bring it back to this equation and plug them in. 156 times sine 2 pi 1.5 times 10 to the 8 t minus 2 pi x divided by 2. And so if we take a look at this, we can already start to plot this graph. I've got a picture of it over here that I've plotted already. You can see up here the maximum amplitude that it reaches is 156, and likewise down here negative 156. At the origin, it passes through the origin, 0, 0. And then each of these points we can consider like nodes on the oscillating wave. One whole period of the wave goes down, up, and back down. And those points that actually begins and ends at one whole period, that's actually 0 and 2 over here. That means these points in between, that is 1 in the middle, 0.5 at the lower amplitude, and 1.5 up top there. And these were all plotting it with t equals 0. Now, for the second part of this problem, we're going to plot the graph at a time t that's 1/4 of the wave's period. Well, we saw from graphing it the first time that the period is just equal to 2. So 1/4 of the period t, 1/4 times 2, or just a half. So what that 1/2 is going to do is it's just going to shift the graph slightly. It's actually going to shift it backwards by just 1/2. So all of these points that we've labeled here, they're just going to move back. So let me draw a new graph here. Instead of it passing through the origin here at x equals 0, the point that was at 1/2 will now be moved a half the way back. Now this is the new 0.5. Make that a little cleaner. This is 0. This is 0.5. The amplitude that was at 1.5 is now at 1. That means it's crossing through the axis at 1.5. And then at 2, it's actually back down at a bottom rather than being on the axis where it was previously. And that just comes from t equals 0.5, causing the whole thing to shift back by 0.5.